I have the integral of the square root of x times the quantity x squared minus 3x plus 4 dx. Now here I have a product, and we know that we cannot integrate each part of a product individually. I have to, in this case, use some algebra first and distribute so that all my terms are added or subtracted. So I'm going to have the square root of x times x squared. Well, the square root of x, remember, is x to the 1/2. And so x to the 1/2 times x squared would be adding those exponents. So my first term would end up as x to the 5/2. Then I would distribute x to the 1/2 to the term negative 3x. So I'm going to end up with negative 3x to the 3/2. So adding the exponents 1 and 1/2 is 3/2. And then finally, x to the 1/2 times 4 is going to give me plus 4x to the 1/2 dx. Now that I have terms which are added or subtracted, I can integrate each piece separately. I could not do this when I had a product. So now let's apply the power rule to each term. So I'm going to have x to the 7/2. I'm going to add 1 to 5/2, or add 2/2. Giving me 7/2. And then instead of dividing by 7/2, let's multiply by the reciprocal 2/7. And then the second term, I'm going to have negative 3 in the front, that coefficient. I'm going to have x to the 5/2, if I add 1 to 3/2, times 2/5 in the front, times the reciprocal. And then plus 4 times x to the 1/2 will become x to the 3/2 times the reciprocal 2/3 in the front plus c. So now this is the antiderivative, but I'm going to simplify the coefficients here, leaving me with 2/7 x to the 7/2 minus 6/5 x to the 5/2 plus 8/3 x to the 3/2 plus c. And here, if I want to turn them back into radical form, I would have 2/7, and I'd have the square root of x to the 7th minus 6/5, the square root of x to the 5th, plus 8/3, the square root of x cubed, plus c. So here the rational exponent has a denominator of 2 in each case, so that would make it a square root. And remember, we don't put the 2 when we're referring to square roots. So this would be my answer in radical form. Here I have the integral of the quantity t squared minus 3 all squared dt. So here I have a composition, and in order to move forward, I want to distribute this out so that I have a bunch of terms added together that I could apply the power rule to. So I have really t squared minus 3 times t squared minus 3 dt. And so if I distribute this out, t squared times t squared is t to the 4th. Then I'd have a minus 3t squared minus 3t squared, so minus 6t squared, and then finally plus 9 dt. So just make sure we don't distribute the exponent up here, that we multiply it all out. And then, since I have all these terms added or subtracted, I can apply my power rule here. So I'd have t to the 5th over 5 minus 6t cubed over 3 plus 9t. So remember, if I have just a constant, I'm going to get a variable behind it, and our differential is dt, so the variable is t, and then our generic constant plus c. And I can reduce these values. 6 over 3 would become the coefficient 2, so negative 2 there, so I'd have t to the 5th over 5 minus 2t cubed plus 9t plus c. here I have the integral of 6x cubed minus 4x squared minus x plus 5 all over 2x squared dx. So I have a quotient. I cannot find the antiderivative of the numerator and denominator separately. In this example, I want to use algebra first because I have one term on the bottom, so I want to split this up. I want to take each term in the numerator and divide it by the one term in the denominator and reduce each term. Let's go ahead and reduce each term here. So the coefficient 6 divided by 2 is 3. So I'm going to have the integral of 3, and then just an x is left over, so x squared is subtracted from x cubed, so 3 minus 2 is 1, x to the 1. In the next term, 4 divided by 2 is 2, so I'm going to have minus 2, and that's it, because x squared and x squared are just going to give me a 1. In the third term, I'm going to have a coefficient of 1 over 2 with a negative, so negative 1 over 2. And then what's going to happen here? So I'm going to have x to the 1 over x squared. And so if I cancel out one copy of x in the top and bottom, I will have 1 over x left over. And we know that has a special antiderivative, natural log of the absolute value of x, so I'm going to leave it like this. And the last term is going to be the coefficient 5 over 2, and then the x squared that's in the denominator will move to the top and become x to the negative 2. It'll move to the numerator and become a negative exponent. So now I am set up to find the antiderivative of each term. And so the antiderivative of 3x is going to be 3x squared over 2 minus the antiderivative of just the constant 2 will be 2x minus 1/2 natural log of the absolute value of x. And then I have plus 5/2 x to the negative 1 over negative 1 plus c. So we'll add 1 to negative 2, negative 1, divide by negative 1. And then we can really just simplify this last term a little bit. So we'll have 3/2 x squared minus 2x minus 1/2 natural log absolute value of x minus 5 over 2x plus c.